So in this video I'm going to talk about the nature of waves. In fact, I'd like to change the color of that, so we could put a bubble around here. And we're looking at the nature of waves. So first of all, I will consider what waves are used for, so uses, and then I will look at transverse waves, and then longitudinal waves, and lastly I will look at some examples of both. So examples, what are examples of transverse waves and what are examples of longitudinal waves. We could actually start with uses. So there's two uses for waves, and these are to transport energy or to transport information. So basically information and energy are the two items which are transferred by waves. Okay, so these are the uses of waves. They are primarily for those two items. What it means is that a wave could transfer energy. For example, a light wave transfers light energy. And also, when you make a phone call on a mobile device, or when you use a remote control, information is being sent from either the mobile phone or the remote control, and that information is being transmitted to cause something to happen to the device that you're pointing at. But then there are two types of waves, and namely transverse and longitudinal, and both of these have examples. An example of transverse waves would be electromagnetic waves. So electromagnetic waves are a type of transverse wave, and sound waves are a type of longitudinal wave. Okay, so let's explain each of them over here, and let's see what transverse waves, or let's see how they do this. How do they transfer this energy or this information? So the way that transverse waves do that is to, so first of all, we know that there are two things to consider for a wave. One, it is vibrations of particles, and two, it is the direction in which the energy is moving. So for a transverse wave, the vibrations are at right angles. At a right angle. Another way to say right angle would be to say perpendicular. So in some books you will see the word perpendicular. But the word perpendicular basically means at right angles. And by right angle we mean a situation like this, where you've got, say, ground here, then you've got vertical line, and that vertical line is making a 90-degree angle. So if this was the energy, this would be the vibrations. I'm gonna need to use a different color for this. So this here would be the vibrations. So here we go. We've got the energy and the vibrations at right angles. The same could be said about longitudinal waves, vibrations and energy, or information. Energy or information. So in this case we have the vibrations and the energy, and we say they are parallel or moving in the same direction. Okay, so this is it. What color can we use now? So this is it. We looked at the nature of waves, and we found that there are three things we can talk about. The first thing is, what are the uses of waves? The second thing is, what are transverse waves and what are longitudinal waves? And examples of these will be the electromagnetic waves. Let's put waves here, and the sound waves. And then this side you have down here we looked at how transverse and longitudinal can be differentiated. So you can differentiate them in terms of the vibrations and energy, or information, vibrations and energy, because there is within this vibration, these vibrations are moving in a certain direction, but the energy is moving in this direction for a transverse wave. But for a longitudinal wave, which is over here, the vibrations and the energy or the information are moving in the same direction. They are parallel. The lines don't look parallel, but it is parallel. That's it.